Okay, so far we've seen two commands, pwd, which has the shell report the current working directory that it is based on, and ls, which allows us to list the contents of the current directory if we provide no arguments, or another directory if we do provide an argument. So now we're going to sort of have a look at, beyond this sort of very basic functions, we're going to look at how we can actually sort of use the terminal to explore the file system and find out about other directories and start working with those as well. So let's run the command ls-f again, just to remind ourselves of the contents of the home directory. Now everybody should have a desktop folder, and we can, as before, use ls -f, and then if we provide desktop as the argument to the ls command, we'll report the contents of the desktop directory instead of the current directory. In this case, I only have two things on my desktop. I don't use my desktop very much. This is the datashell.zip file that you should have downloaded as part of the setup instructions for this lesson, and the data shell directory, which has been extracted from the datashell.zip. If you don't have these, then now is a very opportune time to grab a helper and make sure that you have everything you need to proceed with the lesson. So, likewise, as well as in the same way that we found out the contents of the desktop directory by running ls-f desktop, we can also find out the contents of the data shell directory inside desktop by providing a slightly longer path. So as before, where we saw / using as a separator, denoting that one directory or file was inside another, we're using it here in the same way. We're asking for the contents of the data shell directory, which is inside the desktop directory. Hit return to enter, and you should see the same output more or less in your copy of the data shell directory. This contains a set of example files and things that we're going to be working with today that we're going to use to explore the functionality of the shell. So we can observe the contents of this directory from here, but it's quite if we want to work with any of the files within this directory, we would have to sort of specify all this full path from the current directory, where we would have to say, for instance, if I wanted to work with notes.txt, I would have to specify a full path desktop /datashell/notes.txt. So in cases like this, it's a lot more convenient for us to update the current working directory that the shell is using. So rather than our shell being located in the home directory, it would be convenient if we could move it into another directory so that we could then not have to provide the full path to get to a file. We could just provide the name of a file in order to work with it. The command to do this is cd. cd is being short for change directory. So let's try this example. cd desktop. Now notice straight away that something changes for me. It may or it may not change for you depending on your setup. This part of the prompt here with the tilde character at the beginning is being used to tell me the current directory that the shell is working in. So this is a handy thing that's configured to be part of the prompt because it allows you to get a very quick impression of where it is you are working in the file system at any given time. The tilde here is shorthand for your home directory. So what this means here, what this means in the previous line is I was in my home directory. What this means in the current line is that I am within the desktop folder within my home directory. We can run ls again, and as expected, inside our desktop directory we find the data shell folder and the datashell.zip file. We can then move inside of data shell by running cd space data-shell. Press enter to execute that. ls one more time, and we can see this is now equivalent to the above command where we were specifying the full path into the data shell directory. Let's do one more. Let's do cd into the data directory as well. So just to check that everything is working, has worked as we expected, we can run pwd again. As expected, this now reports that we are within the data directory, which is within the data shell directory, which is in the desktop, which is inside my home directory. And then we can take a look at the contents of this directory in the same way by running ls-f. And again, we see various sets of data files, and we see various subdirectories as well. So far, we've focused on how you can move down the file system, that is, move into directories. But we also often want to do the opposite, which is to move back up. For instance, we are currently in data shell/data, but what if we want to go back up and get just into the data shell directory? There's a special shorthand for this in the shell, which is, just cd ... If we execute that again, and you can see that our working directory has ended up being data shell, not data anymore. One thing that's worth noting is that this use of double dots here is quite commonly, is a universal for all shell commands. So this is not a special capability of the cd command or the or ls or anything. But anytime you want to specify the location of the file, and you need to, relative to the current directory, and you need to indicate a directory above the level you are currently in, you can use ... to do so. Similarly, there is another sort of equivalent for the current directory, which we are currently working in, which is a single dot. So for instance, if I do ls and dot, this is the same as just running the ls command without a dot. The default behavior of ls is to list the current directory, and ls dot is just explicitly telling ls to list the contents of the current directory, so there's no difference in the behavior there. It's worth discussing now one common thing that tends to go, that can happen by accident and be a bit confusing. And that is what happens if you run the cd command without providing it an argument. So every time we've used cd so far, we've told it which directory we'd like to change to. If you just run cd by itself, just hit enter after only cd, you find you end up back in your home directory. So much in the same way that ls has a default behavior, which is to list the current directory, cd has a default behavior if an argument is not provided, which is to change to your home directory. We can just confirm that we're in our home directory by running pwd. So we've ended up back in our home directory, but we want to be inside that data shell/data directory where we were in before in order to work with some of our examples. So we need to do some more CDing in order to get back to where we wanted. Previously, we ran 3 separate CD commands to get to the right directory, but we can combine all of those together into a single by providing the full path to the location we would like to change directory to. So in this case, that would be cd space desktop is the first directory, and again we're using a / to denote different levels of the file system. We're then moving into the data shell directory, another / we want to move into the data directory within data shell within desktop. Hit return on that, and indeed another pwd shows that we have ended up where we wanted to be. So in this example, we say that we have used a relative path to specify the location we would like to change directory to. Any path that does not begin with a slash, here, as in the example here, is interpreted relative to the current directory. So in full, this command means change into the data directory, which is inside the data shell directory, which is inside the desktop directory, and then implicitly, because there's no / here, that we know that the desktop directory is supposed to be inside of the current directory. When we run the pwd command, however, notice that it does have a / at the beginning. If a path begins with a /, this is known as an absolute path, and it means that the location is with respect to the root of the file system. So in this case, pwd tells us the whole root, the whole sort of path to the file with respect to the root. So pwd reports an absolute path, because in this case a current path would, and if pwd was just to report a relative path, that wouldn't be useful information. In this case, we want to know where we are in the file system, so it's useful to get an absolute path as output.